So here's our big lesson for today. We're going to do a little tiny look back last couple of days, the second fundamental theorem of calculus. If you remember that, you'll remember that if you're given that g of x is some function defined by an integral, a definite integral from a constant to x of f of t dt, if that's our function, our first derivative would be f of x. And you've learned basically what that means. You take that x and you plug it into any t's that are in this function. Right? That's what this means, is f of x. Alright, well, we're going to learn a very famous function that is defined by an integral. That function is this one. By definition, the natural log of x is equal to the integral from 1 to x of 1 over t dt. If that's the case, hopefully some of you are already applying the second fundamental theorem of calculus to this equation. I'll give you a second to do that. Good, you probably came up with this idea. That if that is my function, or in other words, if g of x is this natural log of x, then by the second fundamental theorem of calculus, my first derivative would be the same as the derivative of natural log of x, or in other words, 1 over x. So, in a nutshell, oh, here's my nutshell. If you didn't get that much, in a nutshell. Here we go. Here's our whole function. The derivative of natural log of x is 1 over x. Sometimes it's written this way. You can now, if you'd like, add that to your long list of other famous derivatives that you know. You know that the derivative of x to a power is n times x to the n minus 1. You also know the derivative of sine of x is cosine of x, and all your other derivatives of all your other trig functions. Well, now you can add this to your list. The derivative of natural log of x is 1 over x. With that then, that takes us to our next set of rules. Once you've learned your derivative rule, you can now apply that with a product rule, a quotient rule, a chain rule, implicit differentiation, and I'll give you quick examples of that. A product rule. Let's say our function h of x equals x times the natural log of x. Well, now since we know the derivative of the natural log of x, I can apply it here. The derivative will be f times g prime. Right, derivative of natural log of x is 1 over x, plus the derivative of the first one, 1 times the second function, natural log of x. We clean that up, and we get the derivative is 1 plus the natural log of x. And there's an example of the product rule. Let's look at an example of the quotient rule. So maybe I have something that looks like this. The natural log of x divided by x. For our quotient rule, follow just like we did before. We take the bottom function, so that's x, times the derivative of the top function, which now you know is 1 over x, minus the top function, times the derivative of the bottom, which is 1, all over the bottom function squared. And we clean that up, and we get 1 minus the natural log of x all over x squared. So as an example of using that newfound knowledge to product rule and a quotient rule. Now let's look at a chain rule, because this is really the one that's going to be most used. And I'm going to give you one quick example, but then you can look at the other videos to find specific examples from your homework. But here's one quick example of the chain rule. Let's say our function is the natural log of not just x, but something different, like the natural log of x squared plus 3x minus 7. Remember, the chain rule says you follow the rule. Just pretend this is one variable, like u, and we're going to write the derivative this way. It will be 1 over whatever's on the inside, which is x squared plus 3x minus 7, times, if you remember the chain rule, times the derivative of the inside, which is 2x plus 3. And we clean that up a little bit, and we get 2x plus 3 all over x squared plus 3x minus 7. Okay? The book actually has the rule written this way. The derivative in terms of x of natural log of u equals 1 over u. Right? You do it just like you did before. still multiplied by the derivative of the inside times u prime. Okay, and we're going to use that. Again, you can look at the other videos to see how those work with your homework problems. That's the chain rule. For implicit differentiation, again, let's say we have a function that looks like this. Actually, since it's implicit, it's going to look kind of different. And let's say it looks like this. If I have y, natural log of x, plus x plus y squared, we'll make it tough, equals 3. If you remember, I can still use this with my newfound knowledge to implicit differentiation. Here I have a product rule. That's going to be y times the derivative of natural log of x, which is 1 over x, plus the derivative of y, which is dy dx, times the natural log of x, plus 1, plus 2y dy dx equals 0. Combining my like terms, I get this. Dy dx times the natural log of x plus 2y equals 1 minus y over x. Or in other words, actually negative 1 minus y over x. Now solving for dy dx, we get negative 1 minus y over x whole over natural log of x plus 2y. You would probably go and clean this up. I'm not going to right now because I feel that you guys can probably do that on your own. But realize that we can still use this newfound knowledge of the derivative of the natural log of x being 1 over x to a product rule, a quotient rule, a chain rule, and implicit differentiation. On your homework, you'll also have to remember how to do a second derivative if needed, how to apply this to an equation of a tangent line. Remember, here's your equation of a tangent line. And also how to find relative min and relative maxes. Remember, you have to find the derivative, set equal to 0 or undefined to that number line. You can find out when you have a relative min or relative max that way. So good luck on your homework. You have a couple other videos showing you that. You also will have on the blog, it all worked out. If you don't want to watch the video, you can just look at the worked out problems in a PDF format. Okay, good luck.